Hi everybody. What we're going to go through is if you were given a matrix transformation and you were asked to find the original matrix. So we're going to go through how to go through it and go through an example. So in other words, if you're given the input and the output of the transformation, we're going to ask you to find the matrix that they put through this to give you that output. I'm losing my voice, so bear with me for a second. Alright, so before we get started with that, we're going to do a quick review of multiplying matrices. So when you multiply, let's say A and B together, the product C is only defined when the number of columns in the first one and the number of rows in the second one are the same. So these numbers have to be the same number to be multiplied. So hopefully you remember that. And one cool thing is that, or I guess it's, well, not cool, but like the number of rows of the first and the number of columns in the second, those go on forward to be the number of rows and columns in the product. So something that will be useful to us today. So if we are given a set of variables that go into our transformation, and then we are given the output of the transformation, we need to be able to figure out how big the matrix, the original matrix, is going to be before we start plugging in those numbers. So let's say we are given a list of 4 variables. So this would be like x1, x2, x3, and x4, right? So this would be a column matrix with 4 rows and 1 column, right? So, and then this would output, let's say this outputted 3 numbers. So what we're going to do, we're going to use the stuff we learned up here, or we reviewed up here, to find how big, how many rows and how many columns are in our original. So, let's start with this one. Let's start with the number of columns. So I know that the number of columns has to be the same number as the number of rows in our second matrix we're multiplying. So that means that there will be 4 columns in our input matrix. As well, we know that the number of rows in the original is the same as the number of rows in the output, so then we will have a 3 by 4 matrix going into this. So today we're focusing on finding what matrix A is. So figuring out how big matrix A is very important when we're trying to find all the numbers inside, because if you don't know how many numbers you find inside, then you're going to be in big trouble. So with that said, let's get started. Alright, so if we have a look at the screen, oh, my apologies. We will have the example up on the screen. We are being asked to find the standard matrix for the transformation defined by T with x1, x2, x3, and x4. And the output is whatever that is on the screen. So, so basically what this is asking us is to find the matrix that is transformed and write it as a matrix. So, using what we knew on the last slide, to make this easier for us, we are going to start out by writing these in column form to help us. So we need to write it in A, x equals B. So this is B and this is x, like your variable matrix and then your output matrix. So as we know, vectors are lists, but we can also see them as vertical matrices with only 1 column. So we're going to write that, we're going to change the commas into like separating them into how many the rows. So if we start with our variable matrix, we have x1, x2, x3, and x4. And then we actually have only 3 here. We have 1, 2, and 3. So we have negative x1 minus x3, we have 5x4, and then we have negative x2 negative x1 minus x3 minus x4. So that, and then we know that, okay, we have, I just did it on the last slide, but we have 3 rows and 1 column. We have 4 rows and 1 column. So that means A has 4 columns and, let's move this over. I'll move this over, sorry. So that means A has 4 columns because it's the same as this. And then we have, then we have 3 rows to fill. So this gives us, so I'm going to have to fill a 3x4 here. So I'm going to have 3 rows and 4 columns. So that will be about yay big. So it might be a little bit shorter. So if we go back to when we learned how to multiply, we remember that we multiply each row in here by each column at once, and then once we finished each row, we're going to multiply by the next row by the column, and then so on and so forth. So that's going to happen 3 times because we have 3 rows, and that'll give us the 3 output rows here. So if we look here, we have negative 1 x1s here and negative 1 x3s here. So that we would have to put this, because we multiply this number by this number, then we multiply this number and that number, and then add it to this number times this number. So if we see a pattern there, we're going to be able to, actually, see if I erase these. So if I multiply the first number here and by this number to get an x1 term, I would have a negative 1 here. And then I have no x2 terms, so there'll be a 0 here. I have negative 1 x3, and I have no x4 terms, so that will also be a 0. So hopefully that's understandable. So let's move on to the next one. So in this one, I only have an x4 term that is multiplied by 5. So that means that the spot that gets multiplied by the x4 term, or by the x4 in this one, will be a 5. And the rest of these will be zeros. And so in the last one, we have negative 1 of each of them. So the entire row will be full of negative 1s. So these look like, this looks like a scary question, but once you have a hang of it, this is not that much of a challenge, as long as you are able to understand. If you have a good background of multiplying these, then you're going to have a good idea of how to work backwards to find what you had originally. So the final answer would be this matrix over here. So if I write it out again, okay, let's see if I can find another example. All right, so here's the second one. So once again, our first step will be to write it out in column form as opposed to list form. So I'm going to go ahead and do that. So our x1 will be, once again, x1, x2, x3, and x4. Then this one will be x4, x1, x3, and then our x2. And then, do I have too many items on the list? Okay. And then x1 minus x3. So now we can visualize it better. We see that we have 4 rows and 1 column in our variable matrix. So we have 4 by 1 there. Then we have a 5 by 1 here. So remember that this number needs to be the same as this number. So the number of columns in A. And then we have this number is the same as this number. So A will be A will be a matrix that has 5 rows and 4 columns, so it'll be a bit taller. And then now we can start working backwards once again. So we remember that, let's see, 5 rows. So we see that our output has one x4, and that okay, this one actually has, this one has an x4 in it, so that means that in the item in the fourth column of the first row will get multiplied by the x4. So that means that there will be 1 in this spot in the matrix that will be following 3 zeros, because there are no x1, x2, or x3 terms in this one. We also have x1 in the second one, and then when we multiply, we have we're going to have the spot multiplied by this one by that one. So then there's an x1 here, so we're going to plug in a 1 there, and then there's none of the remaining ones there, so we'll have zeros in the other spots. And then we have an x3, so that means the third spot in the third row will have a 1 to give us 1 x3 in the output, and then 0 is everywhere else because there's just an x3 and no other variable. And then in this one we have an x2, so in row 4 column 2 we will have a 1 to satisfy that requirement, and then we have no other variables, so these will be zeros as well. And then finally we will have 1 x1 and then a minus 1 x3, so we'll put a 1 in this spot. There are no x2s, there's a negative 1 x3, and then there's a 0 there. And once again we will have our matrix A. So hopefully that makes it a little bit clearer and will help you find the original when you're given the input and the output, and you're asked what went through this process. All right.